Welcome all of you to this video. In the previous video, we learned about parallelograms and its features. Today in this video, we will study about some special parallelograms. The teacher in the class asked the children to identify this figure. Can you tell what shape it is? Think. Well done. Opposite sides are parallel and of equal measure, and the opposite angles are also of equal measure. Hence, the figure shown is a parallelogram.
Ramesh, Raju and Meena. Now, you also make a parallelogram.
Ramesh, Raju and Meena make these figures.
Now, can you tell me how you have drawn your own figure? Ramesh, tell me first.
Teacher, I know that in parallelogram, the opposite sides are of parallel and of equal measure. So, I made this parallelogram with the help of these four sides of equal measure, in which the opposite angles are also equal.
Very good, Ramesh. All the sides of this parallelogram are of equal measure. Therefore, we can call it a special parallelogram. Do you all know its name? It is a rhombus. Let me tell you an important thing related to the rhombus. If we make a special kind of kite-shaped figure whose four arms are of equal measure, then you can see that we get such shape. Now, if we fold the shape respectively with respect to both its diagonals, we find that the triangles formed on folding are mutually congruent, from which we can conclude that the angles in this shape are equal. Also, if we fold this quadrilateral with respect to the lines connecting the middle points of its sides MN and OP and the sides NO and MP respectively, you can see that the sides NO and MP and MN and OP are parallel. This means the opposite sides of this shape are of equal measures and parallel to each other, and we have just seen that its opposite angles are of equal measure, which makes this shape a rhombus. But we made this shape with the help of a kite. So, what do you think about this rhombus now?
Teacher, we can say that the rhombus is a shape that has the characteristics of both the parallelogram and the kite. If we discuss its diagonals, we will find that both of its diagonals are not of equal measure, but they bisect each other.
Perfect. So let's now write the characteristics of rhombus with the help of these two figures, which are as follows. Come on, Raju. Now discuss the figure you have made. Tell me, how did you make this shape?
I have created this shape keeping in mind all the features of the parallelogram. But in this figure, I have drawn all the right angles. Is it a parallelogram?
Yes, Raju, it is a parallelogram, but it becomes a special type of parallelogram because all its angles are right angles, and we call this particular parallelogram a rectangle. If we draw the triangles PQR and SRQ appearing in this rectangle separately on another paper and observe, you can see that both triangles are congruent, with the help of which we can say that both diagonals of the rectangle are of equal measure. So, now what can you say about the rectangle?
We can say that the rectangle is a parallelogram whose all angles are the right angles and the diagonals are of equal measure and the diagonals bisect each other.
Well done, Meena. Let us now see the shape you have made. Tell me, how did you make it?
Teacher, I have made a parallelogram whose four sides measure equal and all the angles are right angles. Is this also a special type of parallelogram?
Yes, Meena. We call such a parallelogram square. We can also call a square a rectangle that has the same measure of all arms. Since the opposite sides of the square are parallel and all the sides are of equal measure and the opposite angles are also of equal measure, these characteristics of the square correspond to the characteristics of the rhombus. Therefore, we can say that the square is a quadrilateral in which all the features of the parallelogram, rhombus and rectangle are present. So kids, can you tell me about the characteristics of square on this basis?
Sir, all the arms in the square are of equal measure. The opposite sides are parallel. All angles are right angles. And since it is also a rhombus, its diagonals are perpendicular to each other.
Very good, Raju.
Today in this video, we learned about rhombus, rectangles and squares along with their characteristics. In the next video, we will see some examples based on these. Welcome all of you to this video. In the previous video, we learned about rhombus, rectangles, squares and their characteristics. Today we will see examples based on rhombus. If the perimeter of the given rhombus ABCD is 100 cm and the value of diagonal AC is 14 cm, can you tell the value of diagonal BD? Pause the video and try it yourself. Since we have to find the value of diagonal BD, first we draw diagonal BD, which intersects the diagonal AC at point O. In the previous video, we learned that both diagonals of rhombus bisect each other vertically, with the help of which we find the measure of AO, which is 7 centimeters. In the question, we are given the perimeter of ABCD as 100 centimeter. And we know that all the sides of the rhombus are of equal measure, using which we find the measure of side AB, which is 25 centimeters. Now can you tell what we need to do to find the measurement of diagonal BD? We can see that triangle AOB is a right-angled triangle, in which we find the measurement of BO using the Pythagoras theorem, which we get 24 centimeters. With the help of this equation, we can say that the measurement of BD will be 2 times the measurement of BO, that is 48 centimeters. In this way, we find out the answer to our question. Today in this video, we saw an example based on rhombus. In the next video, we will see a question based on square. Welcome all of you to this video. In the previous video, we saw an example based on rhombus. Today, we will see questions based on square. If ABCD is a square, what will be the area of the shaded region? Pause the video and try it yourself. We are given that it is a square and we know that the sides of the square are of equal measure and all the angles are right angles. So we can say that the sides AB and BC are of equal measure. That gives us a linear equation in one variable, which on further solving we get the value of x as 4. By substituting the value of x in given values of sides AB and BC, we find the correct measurement of the sides, which is 19 centimeters. And since it is a square, each arm measures 19 centimeters. Now we have to find the area of the shaded part, which is triangle BCD, whose area we can find with the help of this formula. But which side will be considered as the base and which one height? Since it is a right-angled triangle, we can calculate the base altitude as any side forming the right angle and the height as the other, and calculate the area of the triangle. In this way, we find the area of shaded part, which is 180.5 square centimeters. Today in this video, we saw an example based on squares.